Morning, ma'am. Myself and Bharat. Today, my seminar topic is about waveguides versus transmission lines in a visual comparison. Introduction to waveguides and transmission lines. Waveguides and transmission lines are essential components in radio frequency and microwave engineering. They are used to guide electromagnetic waves from one point to another point. Understanding their differences helps in settling the appropriate components for a specific applications. Definition of waveguides. Waveguides are physical structures that direct electric magnetic waves primarily at microwave and millimeter wave frequencies. They are typically hollow metallic tubes or dielectric structures. Their main function is to consume and guide electromagnetic energy with minimal loss over a short distance. Definition of transmission line. Transmission lines are conductive structures that carry electromagnetic signals between devices over a range of frequencies. For example, coaxial cables, microstrip lines, and twisted pairs. They are designed to transfer energy efficiently over a longer distance with control impedances. Physical structure and materials. Waveguides are usually made of metal and a hollow rectangular or a circular cross section. Transmission lines can be solid or standard conductors, often insulating or embedded on substances. The physical design impact their frequency range and how they guide electromagnetic waves. Operating frequency ranges. Operate efficiently at microwave and millimeter wave frequencies, typically above 1 GHz. Transmission lines cover a broad spectrum from low frequencies to microwave frequencies. This frequency dependence influence their typically applications and design considerations. Losses and efficiencies in waveguides and transmission lines. Waveguides generally have lower loss at high frequencies compared to transmission lines. Transmission lines may experience higher dielectric and conductor loss, especially at microwave frequencies. As we know that transmission lines may experience high dielectric and conductor losses. The choice depends on the need or for low loss transmission over specific distance ranges. Applications and use cases. Waveguides are often used in radar, satellite communications, and high frequency measurements. Transmission lines are common in radio, television broadcasting, and cable internet systems. Each is selected based on frequency, power handling, and system requirements. Visual difference in design. Waveguides are characterized by their hollow, metallic tube-like structure with a specific cross-section shapes. Waveguides are nothing but a metallic tubes which are in present different types of shapes like circular, rectangular, and square. Transmission lines appears as cables or a printed circuit traces with solid or layered conductors. The visual inspection reveals their physical form and guides understand of their function. Advantages and disadvantages of waveguides and transmission lines. Waveguides offer a high efficiency and low loss at high frequencies, but they are bulkier and more complex to install. Transmission lines are flexible, easier to incorporate into circuits, but may have higher losses at microwave frequencies. The decision depends on the specific system requirements for size, cost, and performance. Conclusion and summary. Waveguides are transmission lines serves different roles based on frequency, application, and system design. Visual and physical differences are key to understand their appropriate use cases. Proper selection ensure optimal performance in communication and signal transmission systems. Thank you, ma'am.